All right, so today we're going to dive into a story that, honestly, sounds like it's straight out of a Hollywood disaster movie. You've got these skyscraper-sized ice cliffs in Antarctica, and the idea is they could just shatter, triggering this catastrophic runaway collapse. It's a super terrifying scenario, and it's been the basis for some of the absolute worst-case predictions for sea level rise. But what if the science behind that big fear is actually changing? It turns out new research is painting a very different picture of Antarctica's future, so let's get into it and break it all down.
And look, this isn't just some fringe theory we're talking about. The world's top climate science body, the IPCC, they actually called this possibility a low-likelihood, high-impact storyline. Now, what that means in plain English is it probably won't happen, but man, if it does, the consequences would be absolutely immense. And, that kind of warning is more than enough to fuel some seriously scary headlines about our future.
And just how high impact are we talking here? Well, some of the most extreme scenarios, the ones driven by this theory that the entire West Antarctic ice sheet could collapse, they were projecting a potential sea level rise of over 15 meters. That's almost 50 feet by the year 2300. So what on earth could possibly cause a disaster on that scale?
Well, it all comes down to a process that scientists have theorized is kind of like a horrifying set of dominoes. Once that first one falls, it could set off a chain reaction that's just unstoppable. And this hypothetical villain of our story, it has a name: marine ice cliff instability.
Okay, so the core idea here is built around Antarctica's massive floating ice shelves. You can think of them like a cork in a bottle, holding back these gigantic glaciers on land. The MIICH hypothesis basically asks, hey, what happens if warming oceans completely shatter that cork? The theory suggests you're left with this enormous, exposed ice cliff that's just way too tall to support its own weight.
Let's walk through this step by step. First, that protective ice shelf, poof, it collapses. Second, you're left with this massive wall of ice, just totally exposed to the ocean. Now third, and this is the really key part, the theory says that cliff is just too tall. It can't support its own weight, so it structurally fails and just crumbles into the sea. And finally, that crumbling exposes a new tall cliff right behind it. And what happens to that one? Well, it crumbles too, and so on and so on. It's a runaway retreat that in theory just can't be stopped. A perfect, terrifying domino effect. So for years, this really frightening idea has been baked into a lot of sea level projections. But it's so important to remember it was just a hypothesis, a process that has not been directly observed happening in this kind of runaway fashion, not anywhere on Earth. So a team of scientists decided, you know what, it's time to put this theory to the ultimate test.
And this is where the brand new research comes in. It was published in the journal Science Advances. And what's cool is the study didn't just use one computer model to test the idea. Nope. They used 3 separate, totally independent ice sheet models: SSM, Stream Ice, and UA. Why? To make sure the results weren't just some fluke of one particular simulation. They really wanted to know if you set up the absolute perfect conditions for missy eye. Does it actually happen?
And they went straight for the jugular, Thwaites Glacier. You've probably heard of it. It's often called the Doomsday Glacier because of its sheer size and how vulnerable it is. So in these simulations, they created an absolute worst-case scenario. They literally programmed the models to just vaporize the glacier's protective ice shelf in an instant, exposing the tallest possible ice cliff to see if those dominoes would finally start to fall.
And the results? Nothing. The runaway collapse simply didn't happen. Across all 3 completely different models, after simulating 100 years of this nightmare scenario, the ice front basically just held its ground. The doomsday dominoes flat out refused to fall.
Now this was a huge surprise. The very mechanism that was supposed to trigger a runaway catastrophe seemed to be a total dud in these more advanced models. So the next really crucial question was, why? What was stopping the collapse? Well, it turns out the models revealed a powerful and pretty unexpected brake pedal.
Right, so why didn't it collapse? If you remove that ice shelf that's holding everything back, shouldn't the glacier just pour into the ocean like water from a tap? The answer, it turns out, lies in a couple of really fascinating physical processes that the earlier, simpler models just didn't fully capture. Okay, this is what the models showed. 2 big things happened the moment that ice shelf disappeared. First, the model showed the glacier surging forward at these incredible speeds. It's like taking your foot clean off the brake. But at the exact same time, that very surge caused the ice to stretch and thin out dramatically, right there at the cliff face. It actually thins out so fast that a super tall, unstable cliff never even has a chance to form. So, in a way, the glacier's own forward momentum acts as a brake on the collapse. Pretty wild, right?
So here's the kicker, the absolute bottom line.
The study found that for this runaway collapse to actually start, the speed at which ice crumbles off the cliff face, that's called the calving rate, it would need to be 25 times higher than what their much more realistic physics-based model says is likely. I mean, think about that. 25 times. That's a huge deal. It really suggests that the original doomsday theory might have been, well, a pretty major overestimation.
So, where does this all leave us? Does this new research mean Antarctica is totally safe? Well, not at all. This study doesn't get rid of the threat. What it does is refine it. It gives us a much sharper, more accurate picture of the real dangers we're facing.
Now, this is a really, really important distinction to make. What this study is challenging is MICI, that specific, rapid-fire, cliff-crumbling domino effect. But it doesn't change the threat from a different process, one that's slower but very real, called MISI, or marine ice sheet instability. That's the unstoppable retreat that happens when a glacier resting on bedrock that's below sea level starts to slide backward, down a slope, into an even deeper basin. That process is still a huge long-term driver of sea level rise.
So yeah, this is not a get-out-of-jail-free card for climate change. Not by a long shot. What it represents is science working exactly the way it's supposed to. It's all about refining our understanding, ruling out some of the most extreme, kind of speculative scenarios, and focusing our attention on the threats we know for sure are real. We're moving from a catastrophic possibility to a more certain and still very serious reality.
And that kind of brings us to our final thought for today. As our scientific models get better and better, they're helping us close the door on some of those really extreme worst-case fears. But what this new clarity also does is give us a much sharper picture of the real, undeniable changes that are already happening. So the question we're all left with is this. As that window of scientific uncertainty starts to narrow, is the window for us to actually act on that knowledge closing too?